Welcome back to Jam Tutors Foundation. In today's video, we'll be treating chemistry, and the topic of today will be the brownain motion, diffusion, and osmosis, with the assumption of the kinetic theory of matter. These are the phenomena that we're going to treat, that is going to tell us the reason why gases behave the way they do. So in today's video, we'll treat the phenomenon explaining the physical behavior of matter. So the first phenomenon is the brownain motion, and this phenomenon was first observed by a botanist called Brown in the year 1827. The year 1827, that was when the first phenomenon that treats the physical behavior of matter was confirmed by the botanist called Brown. What did he do? He was able to suspend some pollen grains in drops of water under the microscope. So with the help of the microscope, he was able to note that these pollen grains are moving in a zigzag form. Alright? When something is moving in a zigzag form, it's moving in a disorderly manner. Okay? So in a haphazard form. So Brown discovered the brownain motion. Okay. So the brownain motion, like I said, is the movement of gaseous particles in a zigzag manner, and it was first observed by a botanist called Brown in the year 1827. So the next one we are going to treat is what? Diffusion. What's diffusion? Have you thought when you spray an insecticide in a particular spot, the reason why the thing gets to the extreme end of the platform where you sprayed it? What's the secret behind it? The secret is what? Diffusion. So diffusion is the movement of a solid particle from a region of what? Higher concentration to the region of lower concentration through a medium. There must be what? A medium. Okay? So the movement of solid particles from a region of higher concentration to the region of what? Lower concentration through a medium. The medium could be the space in which that solid particle was introduced. For instance, when this is the medium, let's say this is a passage, right? This is a passage, and you introduce an insecticide here. This area you first sprayed this insecticide is what is being referred to as what? The region of what? Higher concentration. Okay? So when you start perceiving the odor from these other regions, right? From this other region, let's say this is the end of the medium. When this solid particle spreads to this other region, this other region is being referred to as what? The region of what? Lower concentration. Okay? And this passage, the passage where you sprayed that insecticide, is what is being referred to as what? The medium. This is what? The medium. This place is what? The medium. So the movement of solid particle from the region of higher concentration to the region of lower concentration through this medium is referred to as what? Diffusion. Okay? referred to as what? Diffusion. Now diffusion is fastest in gases than in solid. This is the order of diffusion. We have fast, slow, slower. In gases, it is fast. In liquid, it is slow. While in solid, it is slower. It is extremely slow. Gases diffuse in seconds. Liquid in minutes. While solid takes years to go. So this all about diffusion. Let's go into osmosis. So what's osmosis? Osmosis refers to the movement of water molecules. Osmosis is a special case of diffusion. It's the movement of water molecules from the region of higher concentration to the region of what? Lower concentration through a semi-permeable membrane. So for instance, this is a water. Let's think this is a beaker of water. Right? This is of water, and this is a bean seed. This is a bean seed. So you can agree with me that the water molecules are in high concentration in this beaker of water, while this bean seed has a lesser concentration of water. So the movement of this water in this beaker through the membrane of this bean seed is what is being referred to as osmosis. When this water passes through the membrane of this bean seed into the bean, it is referred to as what? Osmosis. This membrane is called a semi-permeable membrane because it allows water to pass through it. That's the reason why it is being called a semi-permeable membrane. Water passes through it. So osmosis refers to the movement of water molecules. It's a special case of diffusion from a region of higher concentration to a region of lower concentration through a semi-permeable membrane. That's what osmosis is all about. Okay, so this is the phenomenon that explains the physical properties of matter. We will not go into the kinetic theory of matter. So the kinetic theory of matter, the first theory states that the particles of a gas are in constant motion, colliding with one another and with the words of what they contain. So the particles of a gas are in constant motion, colliding with one another and with the walls of the container. Okay, so that's the first theory of theory of what? Matter. Secondly, the collision of the particles are perfectly elastic. The collision of these particles are perfectly elastic. So this was what happens when these particles collide or hits one another. There is no change or conversion of energy from one formula to the other. What happens is this: one of the particles, the energy reduces. It's either one, the energy of one increases and the other reduces. There is no net conversion of energy from one form towards another. So that was why they said the collection of these particles are perfectly elastic. Like it rebounds like an elastic rubber. When these particles hit the wall of the container, it rebounds like an elastic rubber. So the third kinetic theory of gases, the third one states stop. The volume occupied by the gaseous particle itself is negligible compared to the volume of what? The container. Volume occupied by the gas particles is negligible compared to the volume of the what? Container. Okay, so that's the third kinetic theory of what? Gases. The fourth one states that the cohesive forces binding the gaseous particles are also what? Negligible. That's why the particles of a gas are farther apart from each other. They are not closely related. They are not closely joined together towards each other. They are farther apart. That's why they can move in a haphazard zigzag manner. So the fourth theory states that the cohesive forces binding the gaseous particles are negligible. Okay, and lastly, the temperature of a gas is a measure of the average energy of the gaseous particles. The temperature, it's a measure of the average kinetic energy of the particles of the gas. So these are basically the kinetic theory of gases. The particles of the gas are moving in constant motion, colliding with one another and with the walls of the container. The second one states the collection of these gaseous particles are perfectly elastic. The third one states that the volume of these gaseous particles are negligible compared to the volume of the container. The fourth one states that the cohesive forces binding the gaseous particles together are negligible. And lastly, the temperature of the gas itself is a measure of the average kinetic energy of the gaseous particles. So that's basically the gaseous theory of what? A gas. Kinetic theory of what? A gas. So let's look into the pressure exerted by gases. Note that gases are always what's moving. When you release a gas from its container or a cylinder, it looks for a way to move. So as they are moving, it's either they are colliding with each other or with the walls of what? The vessel in which they are contained. So as they are colliding with, let's say this is a vessel, they are close to vessel. As they are colliding with each other and with the walls of this vessel, these particles exert a little force on the walls of what? The vessel. Okay? So the more they are moving, they are constantly exerting force on the walls of what? This vessel. So the constant force exerted per unit area, these are the areas of the container, it's referred to as the pressure of the gas. And this pressure is always constant at any given area of what? The container or the vessel involved. As the gases are moving, it's either they're colliding with one another or with the walls of what? The container. So as they are colliding with the wall of the container, they are exerting a little force continuously. As they are exerting such force on the walls of the container, this force in these given areas they are exerting the force leads to what we call the gaseous pressure of what? Of the gases. Okay? And the pressure of a gas, in any given area, it's always constant. Okay, it's always constant. It does not what? Change, because the movement is constant. Okay, it's always what? Constant. The pressure of a gas is measured in atmosphere. Atmosphere, which is abbreviated as ATM, or millimeter what? Mercury, or millimeter mercury. But the basic unit, the standard unit of measuring the pressure of a gas is Newton per meter square. Newton is the unit of what? Force. Meter square is the unit of what? Area. So we said the pressure is the force exerted. Per means what? Division per unit area. Right? So unit of force is Newton. The unit of area is meter. So meters per meter what? Square. So this is the standard unit of force measuring the pressure of a gas. Other units are atmosphere and what? Millimeter mercury. So let me give us the equivalent of these units. One atmospheric pressure is equivalent to 760 millimeter what? Mercury, which is also equivalent to what? 101325 Newton per meter square. So these are the equivalents of the pressure of what? A gas. Okay guys, this is the end of today's lecture, and I hope you learned a lot in this lecture. If you have any question, kindly ask on the comment section. And if this is your first time of watching our videos on YouTube, please kindly hit up the subscription button so you get notified each time we drop lecture on your forthcoming channel. Thanks, and see you in our next class.